All right. Well, today's going to be review day. We have a test on Thursday. We got a couple days to review. But today also we have some homework assignments due. So is this going to be the usual where
You know where you'll see me at 1:30.
where you haven't started the homework and you're just going to get it in by 5? Or are there questions about the homework?
There is a question.
Oh, good.
General though.
All right, a general question.
It's on 8.5,
8.5, is that,
like the exercise from the book. 8.5.
oh, exercise, yeah.
Yeah, so
Actually,
there's those.
I did bring the book.
We had that supplemental worksheet.
And you have that supplemental
That
worksheet
was-
one.
yeah.
Wait. You mean it was easy?
It was
Yes.
really funny. We looked at it and
Yeah, exactly.
Well, I'm glad you found it easy.
Okay. Because these are all one-step probes. They're really, they're simple. But
Yeah.
it was kind of confusing with because the range it kind of changes. And you kind of like substitute different ranges, and I just put in the hint like this is the same as this.
Yeah, that's good enough.
All right.
Because, I mean, basically is all you're doing for 8.5, I mean, is you're just quoting one of 8.23a or one of 8.23b, and whether it's a split off on the last term or splitting off the first term.
Yeah.
And you're just doing, like I said, there's like, maybe, there's a dozen of these versions of these, depending on whether this is less than or equal to, or it's n plus 1, or it's n, or, I mean, so yeah. That's
like full credit.
yeah, it's really more to see if you know how to actually do the split off, you know what I mean?
Right.
Could you do the split off if I gave you the left-hand side of 8.5?
Yeah.
You could do the split off. I could say split off the first term or split off the last term. Or
So we have no assignments due Thursday?
well, no, that's correct. We have no assignments due Thursday because Thursday is the exam. So we never have assignments due on the exam. And what about proving 8.23b? That was pretty straightforward.
Yeah.
Was that pretty straightforward?
Really
Yeah.
Yeah.
Okay. So you have homework for me? Great. All right. Okay, well, if that's the case, then let's start a review. Okay, now here's the way I like to do reviews. I would like for you just to do the work. All right, so on this video presentation, there's probably going to be some times where there's going to be a lot of dead time, so we'll probably just skip over those. And I'm just going to let you do all the work on this. All right. So the first thing that we did, at the end of our last exam, we had gotten up to, but not including 3.83. And with the material that's going to be on this exam starts at 3.83, Leibniz is an axiom. All right. So the first homework assignment that you did, let's see if you can do this. Take out a piece of paper. Take out a blank piece of paper, scratch paper. All right. Get out your pencils. Okay. And see if you can prove 3.85a. So here's review. Prove 3.85a. Okay? So I want you to do that. And for those of you who are watching this on video, you can maybe pause the thing now and see if you can prove 3.85a. Or you can just shut, whatever, okay. Okay. So just see if you can do that. See if you can prove 3.85a. You have your equation sheets, I assume.
So, since I'm going to cut this, do you want to have like a splash screen where it says like, work on here? You have a big blank screen.
Oh, yeah, well, we could do
Work
that.
on here. Problem.
Yeah, or they could pause, I mean, you know, it seems kind of useless to have, it seems kind of useless to have to take up, you know,
Just do Jeopardy.
take up time when they can just pause it and do it.
We could do Jeopardy music.
Yeah.
Oh, that's a good idea.
Yeah.
Dun, dun, da, 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 dun, dun, da, 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 dun, da, da, da. So how we doing?
We're doing A, right?
3.85, prove 3.85A, replaced by true.
Oh. Man, I'm rusty.
Yeah.
Well, this is a good review then, huh?
I remember it's only like 3 steps, but.
Yeah, it's very short, but what's the trick? You want me to give you a hint?
No.
No.
Okay. Ooh,
Okay.
good for you. You're right, we're not going to have hints on the exam.
384B, but
That is that? Oh,
I
yeah.
know for a fact we have to use that one.
Oh, yeah.
Good point. How did you know that?
Because I remember. That's the only reason.
Start with the left-hand side. Start with the left-hand side, but then how can you make it look like the left-hand side of 3.84B?
Identity.
What?
Perfect, we get to cut that
We're
off.
proving 3.85A,
Okay.
so let's work on it.
Prove 3.85A.
You would give me a warning as to when you want to come back in.
All right.
Would be nice.
You're taking that.
Yeah. We'll work on my probability homework, okay?
Hate to do that. You're not gonna mock us down for pulling rabbits, right?
Of course not. You have to pull a rabbit out of a hat on this one, right?
No wonder.
Well, how do you make the left-hand side of 3.85A look like the left-hand side of 3.84B?
Or A. Identity equals.
No, I think we want to use 3.84B because this implies this implies this.
Oh, right.
That's not the end.
Yeah, right.
Are you with me?
Same thing either way. I just quoted the wrong one. We'll get mocked down quoting the wrong hint, but doing it right.
Yes. The hint has to be the hint is part of the
Throw
proof.
everybody off.
The hint is part of the proof. If you quote the wrong hint, then that's not. It has to be this, because the hint tells you what you're substituting equals for equals, or what implies what.
Fine.
Are we good?
Yeah.
You got it? Do you have it? You have it, Kyle? Cale, do you have it?
Step.
All right, I'll give you the hint on the first step. Start with the left-hand side. P implies E was replaced by P. And then do for P, do 3.3 where it's P equals true. Replace P equals true, right?
P with
Is that,
equals true.
Oh, yeah.
that's 3, right? So you can say equals true. So with P, replace P with P equals true using 3.3, right?
And we have 384.
And then you use 3.84b, and you know that equivales what?
P equals true, implies E with E replaced by true.
True. And then you know that equals by 3.3.
And
P implies D with Z equals true.
All right? Are we good? Okay, let's come back in. All right. Next one is to prove 3.85b. But now that you've done this,
Super easy.
I'm not doing it.
do we have a, are you on strike?
Yeah, pretty much.
Wait a minute though.
It's exactly the same as you use 3.84C. That's it.
You start with the left-hand side of 3.85b.
The exact
You do
same.
the
Exact same thing. Well, but wait a
C
minute. But wait a minute.
Use
P.
A
Oh,
or
right,
C.
right. You use P. P equivalent true.
Yep.
Yeah, it is.
The Q and is pretty easy.
Alright.
All right, good deal.
So is one of those gonna go on the test?
Who knows?
You do.
I don't. Maybe I haven't written the test yet. Slackers. Okay, next proof. Now, this is before we did those proof techniques, right? So the next one is to prove .4.1. So this is before. This is without using, you know, the proof techniques that came after that. You know, like assuming the conjuncts. Yeah. So just prove 4.1 just straight off.
We can do the, like, get the right-hand side and get to follow from the left-hand side? Or is that one of the proof techniques?
No, that's not one of them.
I think it is. Oh, right. Right. That's not. Well, that's using. Well, that's a good question.
Isn't that like,
That's based on.
Mutual-
Yeah, that's based on mutual transitivity. That's based on transitivity 3.82.
oh, right.
So,
That's fine.
so yeah, that's fine.
Sweet.
Actually, it's easy to do it without that. You could start with the whole thing. Dun 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 dun.
Alright.
dun.
Tip.
What essentially?
We're having a pop quiz.
Pop quiz.
Pop quiz. So your job, if you choose to accept it, is to prove 4.1. This message will self-destruct.
That's not funny.
And why are you grinning?
It's not funny.
Yeah.
By the way, you want to go see Tron? Because I'm most likely going to be here when it comes out.
I really want to see Tron. I saw the original Tron.
Yeah, you want to go?
You would.
I
Sure.
think I'm going to be here.
When is it coming out?
That's the 20th of December.
That's during our break.
Yeah, the original Tron was actually. I told you we had our computer class. A bunch of computer students and I went. It was in Westwood. It was when Westwood was really hopping.
Is it late 70s or is it early 80s?
It was one of those. I think it was late 70s. It was really big deal at the time. I mean, all those special effects was really groundbreaking. Yeah. So are we good with 4.1? Have you you got 4.1? Mason, you got it? No?
Not quite yet.
Kyle, no?
3.64.
Kale, you got it?
And then 3.7.
I think you will use your old friend. Yeah, 5.9 because what's 3.59? P implies Q is what?
Not P or Q.
Not P or Q. So you use 3.5, you can do the whole thing, use 3.59 twice, right?
I didn't do that.
How'd you do it?
I did shunting. Yeah.
Oh, shunting. Oh, ho, ho, ho.
I did 3.
P implies, Q implies P is what? P and?
Q implies P,
P and Q implies P.
which is 76P.
Oh, and you've got it right there in one step.
Wow.
Whoa, good call.
I did 3.64.
I was thinking 359. If you did 359, it would be P or, sorry, it'd be, let's see, P implies Q is not P or Q. So it'd be not P or, not Q or P. And then,
No, it's just not P or Q or P. Wait.
no, it'd be not P or, not Q or P. Right? If you did 3.59 twice.
Oh, on both sides.
Yeah, well, if you did the whole thing.
Right, right.
Or you could start with the right-hand side and have Q, it'd be not Q or P, and that would follow from P. That's another way to do it. Is that what you did?
I had 3.64. And then 3.71. And then right 0 of implies.
Okay, so does everybody have at least one valid proof? Ben?
No, but I'm listening to all of them. So
Well, here, you get out a piece of paper and do it.
I have one now.
Okay, well then you should do
I
it.
didn't wanna be-
You really should do, look, on these review sessions, you really need to be doing these because it's by doing it that you'll remember when the exam comes around, and
Are these proofs on the exam?
some of them are.
Yeah, pretty much.
Yeah, he was famous for doing that. They keep telling him to write stuff down. All right, are we good? Okay, now this next one is a challenge. Prove 4.3 monotonicity of and.
Likely proof 4.1 because you're trying to prove 4.2.
What's like?
Classic mistake.
By the way, it came out in 82.
Oh, 82, you looked it up?
So it's been what? Long time.
92, 2002, that's 28
28 years.
years. I saw that before you guys were born.
Yep. Quite a while.
That's embarrassing.
For who?
Kind of both parties. I watched it the other day. It's really
Oh, I wonder what it would be like on a rerun.
bad.
Is it bad? You know, I saw, you know, Ocean's 11?
Yeah.
Ocean's 10? Wait, was,
Ocean's
11's the
11.
first one.
it was 10 was the first, was the first,
11 was the first one.
11 was the first one. But then who was the one with the Rat Pack? I went back and, I rented the, because that was a remake, it was a remake of Sammy Davis Jr. and Dean Martin or anyway, it was a remake of one and it got like really, really highly rated. I said, oh, I'm gonna go watch the original. Oh, it was awful. It was terrible. It was really highly rated. So maybe the original Tron, you're saying the original Tron might be like that, huh?
But
But for the time, the effects were really,
it's like when they first started using green screens.
yeah.
So it's like, they use all of the like translucent blues, they like painted.
Uh-huh.
But you can tell that the camera only picks up like parts of it, because when they move it, you can tell. But
Oh, you're saying the effects were really bad. What about the story?
it's okay, I guess. I mean,
Well, it's pretty hard to meet. I mean, you know, now they have it down now. I mean, it's pretty hard to beat movies like The Matrix. You know, I mean,
You'd be surprised looking back at the special effects of The Matrix.
oh, even The Matrix is starting to be dated.
Oh, yeah.
Are you serious?
Yeah.
No kidding. Well, how long ago was that?
When it came out.
10 years, yeah.
Has it been that long?
yeah.
Jeez.
Yeah.
Well, what about Jurassic Park?
Oh, that's so much.
Is that so bad?
Well,
No kidding. You guys think Jurassic Park is really dated?
I watched it the other day, and
It's
I was
a-
actually fairly surprised of how real the dinosaurs looked.
It's okay.
But it's,
Well, man, when that thing came out, that was a huge.
Jurassic Park still looks more real than like movies today because they just look like video games.
yeah.
Movies today, like Transformers and stuff like that.
Yeah,
Yeah, that's true.
like every movie's in 3D.
Yeah, I don't know. The jury's still out on 3D for me. What do you guys like 3D?
No.
3D
I
crap.
watched the Owl movie.
It was okay on with Avatar.
Avatar? Yeah.
But
It was
Ever since then, I haven't liked a 3D movie ever since.
Toy Story 3D was really good.
the Guardians of.
Toy Story, I saw that in 3D. That was all right, I
What
guess.
was the Owl movie? The Guardians of.
the owls.
Yeah, the Owl movie.
Legend.
Yeah, right, Legend of the Guardian.
That was really good, and it was in 3D. It was pretty good.
Okay, how are we doing on 4.3? This is kind of an involved one, as I recall.
Yeah.
I'm just
Let's do this
blanking on
together.
This is the one me and Mason were sitting in your office for a while.
Oh shoot.
Yeah, how it sounds like we might want to cut in on this to give some hints on 4.3.
You ready?
Yeah.
Oh,
Okay, so it sounds like you're kind of stuck here on 4.3, huh?
4.3 sucks.
Well,
Wow, we got exactly 4 minutes.
let's see. Monotonicity of and. What sort of hints can we give?
Does 3.6 keyword?
I think the way we did it when the hints that I gave before, I think it was 3.59 starting with the right hand side. Well, you know,
yeah.
get it to follow from get the right hand side to follow from the left hand side, because the right hand side has more stuff. In fact, the right hand side has an R in it that's not in the left hand side. So we got to figure out a way to get rid of the R and get it to follow from P implies Q. So what I recommend you do is start on the right hand side and use 3.59 on the right hand side and try to get it to follow from the left hand side. So try that.
Give it another go.
Yeah.
Put exactly 4 minutes out last time. Like, to the second. 6 minutes out. You're still having issues with your machine.
I ordered the cable. The cable's not here yet. So I can't use it until I get.
Did you get the path fixed on Windows?
I didn't. I haven't had time. But I can't get NetBeans to work under Windows yet. I can get it to work from the command line, but I can't get it to work from NetBeans. Like I can compile it in NetBeans and then go to the command line and get it to and run it. But I can't, click on the run icon in NetBeans and get it to run from the IDE. So there's a path, there's something in the path Oh, yeah.
and still a little confused about it.
All right. Yeah, it's Java. You have to have Java to get it to run, so you're actually running.
Yeah, but how does Java tie into the C minus minus?
Well, it's the Java. He uses the Java. He has written a virtual machine for C in Java.
We're writing the machine,
Hmm?
running it.
You're running it.
So we have,
So there's a Java compiler that compiles from C into the C virtual machine, and then you run the virtual machine.
okay.
And then you run the virtual machine on the compiled.
Was that the Java Baki classes, was that the source code that we had to compile?
I don't remember if you can just download the Java bytecode. You might be able to. I think you download the compiled Java bytecode.
Okay. And then we just run it.
Yeah. Well, how are we doing? Did that work? Did that help? What did you get? Not. Yeah, not P and R or parentheses
Q and R.
Q and R, and then not parentheses P. Wait, yeah, not parentheses P and R is not P or not R, right?
Yeah.
Wait, what?
Q,
Or,
Not P or not.
no, or parentheses Q and R, right? Is that what you got?
After you
Well then, what I recommend you do is don't take that R, because you have a not R, right?
sure. Yeah, distributed
Distribute that into the and you're going to have a not. Are you you know how,
Or R.
Wait, so you have a not R, which is excluded.
which is excluded middle,
And identity of and to get rid of the true. And then 3.760 you have to follow from not P or Q. Which
and
is
then 3.59 to get P implies Q.
That's the left-hand side.
Still not?
I didn't follow.
Okay. Now, okay. So what do you have so far? You have not P
Not P or not R.
or not R or parentheses
Q and R.
Q and R. So what you can do is take this. You know how or distributes over and? Let's go back and check that out. Distributivity of or over and, 3.45. Are you with me here?
Sure.
3.45? Or the way or distributes over and is that, P or Q and R is P or Q and P or R. So, so what you want to distribute, take that not R and distribute that over the and leave the other one out. I mean, just bring the other one down.
Right.
Are you with me?
Yeah. Okay.
So, and be sure to keep your parentheses are necessary here, right? Anytime you have combinations of ors and ands, you got to keep the parens, right?
Always.
So then when that distributes, when that
You end up with not R
when that
or Q and not R or R.
yeah, so what happens with not R or R?
That's excluded middle.
Do you remember that by now? Excluded middle?
Yes. It's true. So it's true.
Exactly. Okay, so there's your next step. Excluded middle makes that true. And then what do you have?
Not P or not R or Q.
Well, and true, but so what happens with the and true?
Yeah, I already did
Okay, so the identity of and, identity of conjunction, right? So you're left with what?
Not P or not R or Q.
So, and what are we trying to get this whole thing to do? To follow from this, yeah? So, but while on the right hand side, what we've got so far, this still has an R in it, right? Or a not R? What does it have in it?
Not R.
But
Well, we can use
What can-
76A.
we can use string, weakening. Is that weakening?
Yeah. I guess. No.
Yeah, weakening.
I think it's
Follows
weakening.
from
Weakening the consequent.
Use the follows from version of
something or something can follow from one of those. So
yes,
we can get rid of the R.
yes. By follows from. Ooh, this is a good one.
She's 3.5.
Not P. Yeah.
And then not P or Q
Is
is by 3 point, our old friend who?
3.9.
3.59.
9. Okay.
Plus Q?
That's it.
Is there any other way to do it?
There's always.
I think if you, yeah, case analysis. Yeah, I'm sure. There's an infinite number of ways to prove each one. So the answer is yes, there's another way to do it.
Show me another way.
There's an
Well,
infinite
you
number of
could,
ways.
you could instead of just distributing the R in, you could distribute the P or R in.
Alright, well,
And it would still
I mean,
work
another
out.
way of like going about it, 'cause that's still kind of simple.
Case analysis.
Well, you could use one of the, instead of using 359, you could use one of the other ones, and it would take you way
And
long.
you can try to take the entire thing and get it
And you could-
equal to a previous axiom.
Yeah.
So,
All right.
doesn't,
Are we good?
I mean, yeah.
Okay, then what we did is we did the, we started learning these proof techniques. And the first proof technique we used was assuming the conjuncts of the antecedent. And remember the rule for assuming the conjunct of the antecedent.
You cannot use text of substitution on the conjuncts that you're assuming.
Correct. You cannot do that. And but what you do is you start with which side? You start with the
Right side.
you start with the right side. You start with the consequent, and you have to get it to do what?
Equal or implied true.
Equal true.
Kind
Not
of-
You got to get it to equal true. Yeah? Are we good? That's the idea. Okay, so with this in mind, let's do this. Let's reprove. Actually, this is pretty straightforward. Well, so reprove 3.77, assuming the conjuncts.
The way that affirms by affirming.
We did this already.
This was a homework assignment.
Yeah.
So all of these are homework assignments. Assuming conjuncts of antecedent. So this one, you're going to really have to pull a rabbit out of a hat, right? Because if you're going to reprove 377, let's look at what
We
377
start
is.
with Q.
You start with Q, yeah.
So by definition, you have to pull it out.
Yeah, by definition, you have to pull a rabbit out of a hat. Now, so I leave it up to you. What do you think? Can you search back?
Of equivalence identity.
Can you search back for a Q somewhere and try to and have something with a P or a P implies Q or a, I mean, you know, because what are the conjuncts here?
P and P implies Q.
Yeah, so P and P implies Q. So can you start with Q and get it to have,
We can
Can-
only use equals, right?
yeah.
Go right.
And of course, I gave you a hint on the webpage, but there will be no hints.
Golden rule.
Now,
Golden rule, you think?
Okay, it would work.
are they
No, because you need something with an implies, right?
On a reproof, are they allowed to use stuff after 3.77?
No,
That's cheap.
only the proof technique.
Oh, I got this.
Oh, you think so?
I think so.
Hmm.
At least I know where I'm looking.
How many steps is it? Just curious.
Oh, yeah, I think I see. I think I see one that would work.
Like shunting.
I got it.
Anytime there's an R, can you assume that if you have like P and Q equals R, or P and Q equals P, can you use that P as like with R replaced by P?
You can use any previously proved theorem or axiom
Right.
with any variable replaced by any expression.
Okay.
But it has to be, you have to do them with all of them.
Yeah.
That has to be all of them. Like you can't selectively, like if you have a previously proved theorem and you want to have the R be replaced by something, but another R in a different place in the expression not, you can't do that. You've got to do all occurrences, with all occurrences of that variable replaced by that expression.
Are we just trying to prove this to be true by assuming that?
Okay, now, yeah, this is a good review now. Remember, the way you use proof by assuming the conjunct of the antecedent is you start with the antecedent and you get it to equal true. And in the process of going through and getting it to equal true, you can use any of the conjuncts of the antecedent as if they were theorems. All right, so what can we use in this particular one, what can we use as a theorem? We can use P as a theorem. We can use P implies Q as a theorem. All right, because those are the two conjuncts. Are you with me?
Yeah.
The conjuncts are P. The first conjunct is P. The second conjunct is P implies Q. So look for an expression in Q with Q. Go back and look at previously, scan your previously proved theorem and find one that has a P implies Q in it. Find one that has a P that also has a P in it. And so start with Q and pull a rabbit out of a hat and get it to a more complicated expression, but one in which you can use these conjuncts. So did you find one?
I used 57.
I think that's the exact one that I would use.
That's what I used to.
So you have P equals by 57 what? Blah, 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 right? Okay. And now what's one of those and now what can you say? Equals by what? Assumption what?
Assumption.
It's assumption P implies Q, and then that's true, and then wherever there was a P implies, that make that true, right?
Then you end up with P or Q.
And then you end up with P or Q,
This is true.
P is true.
but assumption what?
Okay, I was right.
P.
P, right? And then what do you have? True or, that's the zero of or, right? And you got it to equal vel true.
My question is can we use 3.3?
You have to.
Well, we use 3.3 all the time.
Yeah, if you want. That's what I did.
You have to use 3.3 somewhere in there.
You do?
You don't have to.
I don't think so.
I started with
Start with 3.3.
Because 3.3 is P equal vel's true.
Right. I mean, once you got P implies Q,
Yeah.
Okay.
and then you got true equals P or Q.
Oh, true equivals. You have a true equivals in there?
That's what I do.
Yeah, because when you.
Oh, that's
you
right.
assume
With
something-
357. No, that's right. You have the equivals in
You can
357.
start with 3.5.
Right. You do have to use 3.3 because you have 3.57. It has the equivals in there. Yeah. Yeah? Are we good? Mason, you good? Are you with us? Ben, are you with us?
Yeah, I'm done. I'm just filling out the stuff. So you don't do that tomorrow.
Okay. All right. Next one is, let's reprove 3.76E. Reprove, do another one. Reprove,
You want us to assume the conjunct?
yeah, 3.76E, assuming conjuncts.
Those are dumb assumptions.
I don't recall a formal mathematical definition of dumb.
Oh,
There is one?
Yeah, dumb.
3.6, 716.
Mathematical definition.
Oh, that's easy.
It's super.
This is super after the last one.
Hence dumb.
Well, no, I wouldn't say call it dumb. I would call it easy. Right? Because you start with P and parentheses Q or R. You got to get that to
It's
equal
so
vel true. But one of the conjuncts is what? P, right?
Yep.
So assumption P.
Done.
So you have true and then identity of and then you have Q or R, and then assumption Q. So true. Yeah, that was easy. Should have done that one first, huh?
Shouldn't even matter. Waste my time.
Wasting your time. That's funny. All right. The next proof technique that we'll do one more and then we'll call it quits for today. Yeah, let's do a case analysis one. All right. So in 4.5 case analysis, oh, that was based on Shannon, wasn't it?
What?
Case analysis was based on Shannon.
Why is it called Shannon exactly?
Shannon was the name of a mathematician.
It's the name of many mathematicians, I'm sure.
It was like name
It was here. It was based on Shannon. And in fact, I think we proved Shannon. Could you prove Shannon?
I'm sure we did at one point.
You did. Don't worry about it.
How did we prove Shannon?
Yeah, it's not
By
important.
case analysis.
That was pretty good. That is cheating because Shannon is based on case analysis is based on Shannon. Maybe we should try to prove Shannon. Okay. So let's do a case analysis one. So
Don't quite remember how case analysis works.
well, okay. So this will be a good review, huh? Let's prove 3.46. Prove 3.46 by case analysis. Now I have to say on which variable?
P.
On
Pick, take a pick.
P is correct.
It doesn't matter, right?
Well, I mean, whatever,
P's in there a lot, so it's a good one.
I mean,
by case analysis,
you
so,
should be able to do it theoretically with anyone.
You can do it with all of them.
well, but then you'd have to have a case analysis inside the case analysis, which becomes
That form.
ultimately a truth table. Proof by truth table, which we do not like.
Proof by truth table.
All right, so what's 3.46? Oh, we just used that.
So then you have to do it with P is true and P is false.
Correct. So you put 1 and you write that out with P being true, and you write 2 and you write that out with P being false. And then you can prove,
Do you prove both of them?
yeah, you have to prove, and then you prove 1 and then you prove 2. But you need to write them out. And you can prove it, once you write it out, you can prove it any way you want. You can start with the left-hand side, get it equal to the left-hand side, or whatever. Or do the whole thing. Actually, since you have some truths in there,
Yeah, it's just a bunch of zeros and identities.
well, no, I think it's going to be a little bit more than that, right? Because you're going to have, because there's an R.
You end up with Q or R. That's it.
But then what about when it's false?
I'll have to write it.
Well, anyway, you need to write them out. You need to write them out individually. Number them 1 and 2, and then prove 1 and then prove 2.
3.3. And anything and false is false, correct?
Which theorem is that?
The 40, the 0.
That's the zero of and.
What do you call this?
False equivalence, false or false?
False equivales false or false. Is that what you got for one of them?
False would be so true.
That's what the second option is.
Well, and then false or false is false, so false equivales false is true by 3.3, right?
Mhm.
With P replace false, or Q replace false, whatever it is. All right, good deal. So you give me your homework by 5 o'clock today. I'll have it back for you tomorrow. We'll continue this review on tomorrow, and the exam is on Thursday. So we're making good progress here. All right. See you next time.